So in this video, we will look at the current electricity MCQs. Number one, so the relationship is charge is current times time, because the current is defined as the charge per unit time. So we take the T on this side and input the values and get 480 coulombs. So 1 volt, just look at the relationship. 1 volt is the work done for 1 joule per coulombs. Work done of 1 joule per coulomb charge is 1 volt. So that's why 1 joule per coulombs. So which wire has a greater resistance? The wire which will allow less current to flow for the same amount of voltage. It looks like Q is allowing less current, so it seems Q has a larger resistance, and P seems to have, so sorry, not Q, P. P is allowing for the same amount of voltage. Q allows this much current and P allows this much current. So P has larger resistance and Q will have larger area because area means less resistance. Number 4. So if we have a resistance of 5 ohms, we have to calculate the power here from here. And sorry, not power, we have to calculate that which range gives us nearest to the 5 ohm resistance. If we allow a current to pass through it and set up a voltage across this resistor. So if you look at choice A, it gives you 2 divide 0.5 equals 4. All others are far away. So 2 divides to 1 ohm resistance, 1 ohm resistance, 2 ohm resistance. So they are quite far. So A is the nearest choice. So it's the correct choice. Number 5. Again, we use the same relationship. I is equal to charge per unit time, input the values and get this value, which is given in choice A. 3 1.5 volt cells. What is the advantage? The battery can supply a current for a longer time than a single 1.5 volt cell. That's the biggest advantage of putting batteries in parallel. Again, the same relationship. So input the values, get the answer, and 1.5 amp is the current. So 0 to 2 amps will be the ammeter range that can be used. Number 8. 3 identical cells connected in parallel. Advantage, each cell takes longer time to run out because there is less load on each cell. The load is divided among all 3 cells. Number 9. So we have a charge flowing for this much time, and this charge gives us the energy. The charge times voltage gives you the energy, which is this much. So we choose the C and D, and then power will be energy per unit time divided with time. You get 1.8 megawatts, which is this one. Number 10, a 10-meter length whose area is 0.4 and resistance is this much. So relationship is here. We input it like this and we get this answer. Just watch how this relationship is used. So if there is a R is proportional to length over area, R is equal to 2 ohms times the relationship between the two lengths to their areas. So length, area over length, because R will be multiplied with area and divided with length to get the resistance the other way, the other resistance. Number 11, I is equal to Q over T, input the values, get the answer, and nearest answer is given in choice D. Which physical quantity is produced by a calculation where charge Q is multiplied by potential difference V? We've just seen it here. Q multiplied V is energy. So energy. 3 10 ohm resistors. Network X connected in parallel, Y connected in series, Z 2 in parallel, 1 in series. So smallest resistance to the largest resistance. X will have the smallest resistance. Z will have medium resistance and Y will have the largest resistance. You can do this by calculation or you can use your intuition, your knowledge that resistors in parallel become half and two identical resistors in parallel become half and two identical resistors in series become twice. So we have an 18-volt supply and asking what is the potential difference across the 2 ohm resistor. For this, we have two 8 ohm resistors in parallel. So their equivalent resistance will be again 2 8 ohm in parallel, equivalent will be halved. So it will be 4. 4 plus 2 will gives you 6. So across 2 will be total 18 multiply like given here. We have a voltage V2 is across 2 ohm resistor is given by the total voltage V, which is 18 multiplied to the resistance of the resistance from where we're getting the voltage and the total resistance. So 2 over 6 multiply 18 gives 6. And this is given in choice C. Immersion heater, power given, power is equal to V times I. V is given, calculate I. It's very simple calculation. Number 16. So we have a resistance 16 ohms. 4 times length means the resistance is 4 duplicated, 64. And then twice the area means it will be half, 32. So 32 is given here. Number 17, 3 and 2 ohm resistor, total, make it, add them, makes 5, 12 over 5 gives 2.4, given here. Number 18, input power. So input power is equal to V times I, voltage times current, 60 volts, given in B. Number 19, a charge for this much time, I is equal to Q over T, gives you 8,000 amps. So 40 coulombs charge from the flash, lightning flash for 5 milliseconds can have 8,000 amps current. In order to blast a missile, we need something like 600 amps. So that's way too much. So what will happen when this current, when this lightning falls on something and conducts through it? Oh my God, that will be plasma. So number 20, 1 volt is equal to 1 joules per coulomb. We have done this before. Number 21, what is the graph? So this is the graph and the data. So the wire at 0 is 1 ohm and at 100 is 1.4 ohm. So 100 degrees increases its resistance by 0.4. Another 100 will increase 0.4. So that makes it 1.8. Very simple intuition. So we have a lamp Q and a lamp P. So which statement is correct? We will go one by one. So does lamp P has a lower resistance than lamp Q at all currents? No. It's only equal resistance at this much, and then its resistance starts to decrease. Sorry, it doesn't decrease. Actually, the resistance of Q starts to increase. That's why applying any more voltage does not increase the current. Whereas lamp P's current is increasing all the way up to here, and then it starts to decrease. Option C, lamp has same resistance at all high currents. No, they don't have the same resistance. Option D, lamp P has higher resistance than Q at all currents. No, that is wrong. So now the correct choice is lamp P has the same resistance as lamp Q at low currents. That's correct. At low currents, they're both showing the same voltage current relationship. So we have two light bulbs. Filament of L1 breaks. What happens to the reading of ammeter and voltmeter? Well, very tricky question. Before we look at the choices, let's discuss what happens. So, when this filament disconnects, there will be no more current flowing through the circuit. That means the ammeter should read 0. And what about the voltage? So, at the moment, the voltage across this is half of this voltage. Why? Because they are identical. Let's disconnect this one and see what it is. So when we don't have anything here, this voltmeter is connected to this voltage, which is like full voltage from the left side, and this voltage, which is the zero voltage from this side. So full voltage minus zero voltage gives you full voltage potential difference. So this reading will increase. Let's see what are the choices. So ammeter decreases, voltmeter increases. Correct. Which of the following is 1 coulomb, 1 amps per second? It is from the charge current relationship. I is equal to Q over T, so Q is equal to I times T. So I is amp and second is T. 25. Circuit is shown, 3 switches. Which switch gives a resistance of 6 ohms between X and Y? Wow, very nice question. So let's look at all the options before we see why it is the option B. So if you close S1 and open S1, that means we have 3 and 4.5 becoming in series. Remember, we have left S2 and S3 open, just close S1. The total resistance becomes 7.5. Take a note. Now, we close S2 as well. So when we close S2, the resistance of 3 and 3 in parallel will become 1.5, and added to 4.5 gives you 6. Take a note. Now 7.5 and 6. Now when we close S3, what happens? So S3 will mean no current will flowing through the resistor. S3 is short, it is shorted, so S3 will make the circuit flow the current from S3. So the resistance will be only that is coming from here. So 3 and 3 connected in parallel will be 1.5. So 1.5, third choice, if we have S3 closed. Now look at the choices. So 6 ohm resistor, we have got 6 ohm resistor. So we have S1 closed, yes. S2 closed, yes, we closed S1 and we left S3 open. So we had 1.5 from these two plus 4.5, giving us 6 ohm resistor. And this one is just reading the meters in milliamps and then multiplying with resistance gives you the voltage. So 6 milliamps times 300 gives you 1.8. Number 27, which is the graph for a filament lamp. Filament lamp is something that shows deviation from the voltage current linear relationship at high temperatures. So this is shown here. This one is ohmic conductor. This one is impossible, and this one is something we don't study in this course. Actually, it's given no. This one, the voltage across the lamp increases. As the voltage increases, the temperature increases, and as the temperature increases, the so the choice was wrong. Now we look at it. So as we in the voltage here up to here, we see that the curve is going upwards. So any more increase in voltage does not increase the current. The current becomes almost steady at this point. Why? Because here, when you increase the voltage, the temperature is also started to increase. Increase in temperature means more resistance, and more resistance means the current is not going the same way as before. So D is the choice. So we have this arrangement, reading of the ammeter. So first of all, we have to put these two in equivalent resistance. So 6 and 3 in parallel gives you 2. Look at this relationship. This is what we're going to use. R1, 1 over 6 plus R2, 1 over 3. And this gives us this current, which is given in choice D. One switch is now opened and all the lamps are lit. Which switch is open? So all switches are closed. Close this switch, current goes from this one. Close this switch, current starts to going this way. And close this one, current starts to go this way. If you close this switch, that means this light bulb is not on. Okay, there will not be any current flowing through this because we have shorted the circuit. Now, why is this behavior? Is because current is lazy. When it finds a less resistance, it wants to go through there. It doesn't want you to go through high resistance. It is just like water. If water finds a lower plane, it will not rise up. It will tend to flow from the lower plane. So that's why when the switch B is opened, all three are closed. All three light bulbs will be on. Number 31, 12 or 12 volts, 36 watts. Put it in this relationship. The energy will be 360. This relationship is energy is equal to power, which is VI times time. Different electrical components. The filament lamp will not increase the current for voltage, so it is 1. And constant temperature resistor will be 2. Sorry, it will filament lamp is not 1, it will be 3. Sorry. So voltage increased, current does not increase anymore. Okay. Whereas in one, increase in voltage means a lot of increase in current. So that's the other way around. That's wrong. And this one, a steady relationship. The temperature remains constant. This is called ohmic inductor. Number 33, all the data is given. Put then the values P is equal to VI. That gives you I, and that is given here. Three identical resistors connected in parallel. Each cell takes longer time. Three identical cells, three identical cells connected in parallel to a resistor. So each cell takes a longer time because they are in parallel. The load is equally divided for all three, to all three. Use this relationship to calculate the equivalent resistance, and it will be 2 ohms. Resistance is proportional to directly length and inversely area. Use this to calculate equivalent, which is given as 2. And here, first we calculate the current using this, V over R. V is given here, R is here. And then the current passes for 30 seconds, gives us 15 coulombs charge. Sorry, the current for 30 seconds charge means, this current means that this much charge will pass for 30 seconds. Which change causes a decrease in resistor of a copper wire if you decrease its length and if you lower the temperature, because length is directly proportional to resistance, and so does is the temperature. So we have an 80 ohm resistor wire, and another one whose area is 4 times and length is twice. So look at this. If area is 4 times, resistance becomes 4 times less, and this resistance making L twice will make it twice 40, given in here. So number 41. This is the circuit. The lamp is now connected to 4 similar cells. The effect of connecting extra cells is, well, the lamp will have the same brightness, but it will last longer now. This question, again, we have to calculate the voltage across 10 kilo ohm resistor. 6 is the voltage in original supply. So we calculate this using this relationship, and it is 12. Which change will not reduce the value? If you cover it in insulating wire, it doesn't have anything to do with the resistance. If you increase the cross section, its resistance will be half, length is decreased, resistance will decrease, temperature decrease, resistance will also decrease. Well, whichever current and voltage, divide the voltage by current gives you 100 ohms. That will be the choice. So, but make sure you use this milli in your calculations. Otherwise, you will never get the answer. So divide 3 with 30 milliamps gives you 100. 2 with 20, they're all same. Divide any of these, use any of these, should give you 100. Others do not. This one does give you, but then this one does not. So, and the same here. Charge on an electron is negative always, and it flows from negative terminal, positive terminal. So A is the correct choice. So this is the series. This is the 2 series. If series gives you 6, that means each is 2. Connect all three 2 ohm resistors in parallel should give you 2 over 3 ohms. We have a circuit. What happens when circuit switch S is closed? The iron core is magnetized. It attracts iron. It attracts iron and it has attracted the iron. It thing is stopped here. Now, when we open the S switch, this will be demagnetized. It will release this iron. The iron will hit this metal. When the iron will hit this metal, this bottom circuit will be complete. And this bottom circuit completion means the bell will ring. So this switch is so clever that it allows the bell to ring for just ting, and that's it. Because you can clearly see that this iron, upon hitting the metal, will come back. Nothing will keep it there. So that's how it works. Our bells, the sophisticated bells, work. There are bells that you press the button and they keep me. So that's very annoying. This bell, you press the button and it just bells once. Ping. Which pair of graph shows resistance, filament, and current vary with the same time after lamp is switched on? So carefully look at the filament lamp is switched on. There is current, temperature, filament increases, resistance changes. So we can see that as the temperature increases, the resistance and the current has come down. So look at these two graphs. When the current is decreasing, that means the resistance has increased. The first one is the cause and the second one is the output. So if you increase the resistance up to here, you can clearly see the current going down, decreasing. But here, you can see that something has happened. It says here the temperature, due to which there is no more decreasing in resistance. Resistance has reached its highest, and there is no more increase in the resistance. The resistance has reached its highest value. So that means there is no more decrease in current. That's why it is B. A, it's not possible because current and resistance inversely proportional. C, also not possible. In D, why D is not possible is because it is the other way around. That's why. But it is actually possible, and because when you decrease the resistance, the current should increase, and when there is some certain time up to which the current is decrease, the current will increase. But if you look at the wording, it says as the temperature rises. When the temperature rises, resistances do not decrease, they tend to increase, number one. And number two is it says resistance here starting from some point, not zero. But here we see that resistance starting to decrease and it coming all the way almost to zero. That is very, very strange. That's why. So that's been done already. Look at this, and you have to find the effective resistance that can be calculated by this resistance in parallel relationship. Ohm's law means if the temperature is constant. So we have three heating elements in which is the current from the supply lowest and highest. Lowest current will be here and highest current will be here. Why? Because this is series, resistance is maximum, this is parallel, resistance is minimum. This is in between. And these three settings are used to turn the heater's heating, increase the heater's heating to maximum from minimum and in between. We have two resistors and which statement is correct? So we see that the current coming from here is divided into these two and then going this way. So P is greater than Q, that's definite. Okay, Q is equal to R, that is not correct because Q will be larger than R due to the resistance. R is greater than S, no, R and S are equal. And S is equal to P. No, that is not possible because P is the total current dividing into these two resistors. So P is greater than Q, correct choice. Resistance increases as the current increases is given from this because when the resistance increases, the current will start to decrease. Why it is not A? Well, in A, the resistance and current are constant. The voltage current, the V over I, any gradient will be the same. But here, the gradient here will be larger than this one. So resistance has increased here. That's why the current has decreased. This one is not possible. This one is also possible. For this case, so in this circuit, 3 volts and zero point 0.5 amp should go through the circuit. 0.5 amp means the resistance V over R. So resistance should be 6 because 3 divided 6 gives 0.5. And if resistance should be 6, then R should be 5. C is the correct choice. Ohm's law is the condition for this law is temperature must be constant. And if you want to keep the temperature constant, how can you do that? That's something to think about. So there are some conductors that allow higher current without having their temperature increased. They follow Ohm's law and they are called ohmic conductors. Otherwise, every conductor, when a large current passes through it, its resistance increases, and that will decrease the capacity to allow more current, and that's why the curve starts bending. 57, and this is the definition of the EMF. Very simple. So the Ohm's law here again. So look at the X and Y section. Increase the voltage, increases the current. And look at the YZ section. Increase the voltage by the same amount does not increase the current by the same amount. Every point it is decreasing. That's why Ohm's law is not applicable in this region. So Ohm's law is applicable in XY. So you don't want to operate this in this region. You want to operate this equipment in this region. That means you don't want to increase the voltage from here. So maximum voltage for this conductor allowed is up to this point. We have 8 ohms resistor, half length, twice cross sectional area. Well, if length is half, the resistance becomes 16, and if the cross section area is twice, the resistance will becomes 32. Why it's given 2 here? Let's look at the question again. Sorry, half of length means resistance will become 4, and twice area means resistance from 4 will half again and become 2. So B is the correct choice. Number 60, current in the ammeter is the total current from the circuit. So if the current from 6 ohms is 4, the current from here will be a 2. So 4 and 2 will be 6 ohms resistor. Why the current here will be 2 is because the resistance has doubled. That means the current is halved. This is the definition. Potential difference across x, y is the work done in driving a unit charge between x and y. It is the definition of the potential difference across a component. So here, which two resistors have the same resistance? Look at the question carefully. Option B. Option P. We have 2 and 2, and they're halved, giving 1 ohm. We have 1, 2, and 2. That's not 1 ohm. And then here again, 1 and 1 half, that's 2.5 ohms. And here we have again 1 plus 1 and 1 plus 1, 2, 2 and 2 halved. So 2 on the top, 2 at the bottom is same as 2 at the top, 2 at the bottom. So P and S have the same resistance. So this is a V is equal to W over Q relationship. Work done per unit charge. Put the values. 1200 joule is the answer. So here the data is shown. Read it carefully. We have 1 meter and then it is made 2 meters. Everything else is same. So let's look at my calculations. So first we calculate the voltage. 3 times 2 gives you 6. When length doubles, the resistance is also doubled. It becomes 4, and that gives this current, which is given here in this C choice. The definition of EMF, once again. So 24 ohms is only possible from this setup. Look at the other ones, it doesn't give you 24 ohm resistance if you use the relationship V is equal to IR and R is equal to V over I. So we have 10 ohms resistor here, 10 ohm resistor here, 6 is trying, it will go 3 here and 3 here, and that's why 2 ohm resistor will have 3 amps current flowing through it. Potential difference is joules per coulomb. X and Y filament, same material, thicker and shorter. So if it's thicker, resistance is half, shorter, resistance is another half. So X will be brighter lamp and Y will have larger resistance. So calculate the voltage using these two. The diagram is not made, only the word question have word illustration of the situation. We have two series resistors, add them together like this and divide them with voltage gives you the current. Thank you very much.